Welcome to the fourth episode of Dairy Cattle Feed Formulation. I'm so excited that I have covered all the steps for feed formulation in ruminants. It can be applied to beef industry, for dairy cow industry, and today we are going to focus on formulating the concentrate, because over the last 3 episodes we covered how to calculate total nutrient requirements, how to calculate the forage to concentrate ratio, and the amount of nutrients provided by the forage section, and the amount of nutrients that we need to provide through the concentrate. And today, in our fourth episode, we're just going to balance the concentrate. So here is the summary of parts 1, 2, and 3. As you can see, we determined the total nutrient requirements based off the maintenance requirements, milk production, and body weight changes. We calculated the dry matter intake and forage to concentrate ratio, and the amount of nutrients provided by the forage, and the amount of the nutrients that should be provided by the concentrate. And if you remember in the previous episode that I'm going to post the link up here, we calculated the nutrient composition of the concentrate, the amount of energy, protein, calcium, and phosphorus that we need to have in our concentrate. Today, we need to have a look at the feed ingredients that we are using. So basically, when you are formulating a diet, either for ruminants or monogastric animals, doesn't matter, the first step is to divide the nutrients into 2 sections: energy sources and protein sources. So to put it in a nutshell, energy sources are grains like barley, corn, sorghum, and wheat, oat, and any kind of fat, for example, soybean oil, or fat powder. And also we will have protein section, which can be single cell protein, for example, yeast, or it can be plant-based protein, different meals like soybean meal, cottonseed meal, sunflower meal, or it can be animal-based protein like fish meal, meat meal, and so on. So here, if you look at the feed ingredients list that we provided in our previous episode, we're going to use barley, corn, sunflower meal, and cottonseed meal in our diet, in our concentrate. And from this list, we can see barley and corn are energy sources, and sunflower meal and cottonseed meal are the protein sources. So what we're gonna do is we're gonna assign a number for each ingredient in its category. For example, barley is located in energy category. Corn is located in the energy category, right? So I'm going to assign 60% to the barley and 40% to the corn. So in the energy section, not in the total diet, not in the total concentrate, in the energy section of the concentrate, I'm gonna have 60% barley and 40% corn. So to assign these numbers, you need to have nutritional knowledge. Usually, our decision is based on the market condition, for example, based on the feed ingredients price, and also based on the ingredient quality, presence of any anti-nutritional factor. For example, let's say you've decided to use cottonseed meal or cottonseed in your diet, and it has anti-nutritional factors like gossypol, and it can create some problems. I'm not going to talk about anti-nutritional factors in this episode, but you need to consider the limitation of using that ingredient because of the presence of those anti-nutritional factors. So if you are asking, how would you assign these numbers to different ingredients? Based on the market condition and based on the quality of the ingredients and availability of the ingredients, of course. So for the protein sources, I'm gonna assign 75% for sunflower meal and 25% for cottonseed meal. And then what I need to do is just to calculate the amount of energy and protein coming from each category. So for the energy category, as you can see, I'm calculating the amount of NEL, or net energy for lactation, by multiplying the amount of each ingredient by the amount of energy in that ingredient. For example, barley has 1.89 megacalorie energy per kilograms. So that's why I'm multiplying that amount of energy by 60%. And then I do the same thing for the corn, and then I'm gonna add them up to have the final value, final energy value for this mix, which is the energy sources. And of course, you need to reference this table from the nutrient composition of feed ingredients to find the amount of energy and protein and other nutrients in each feed ingredients. So, for example, as you can see here, for barley, we have 10.7% protein and corn has 10% protein. So when you are just formulating the diet, here you are using 60% barley, so 60% times 10.7 plus you're using 40% corn with 10% protein in it. So you're going to multiply 40% by 10, then add them up to have the final value for the, protein in your energy ingredients. And the same idea is for protein mixture. Doesn't matter, it's the same thing. After that, we need to build two equations. One equation for energy and one equation for protein in our concentrate. So the first equation is for energy balance, and the second equation you can see here is to balance the protein. So we will have two unknown variables here. X is the energy sources, amount of energy sources in our concentrate, and the Y is the amount of protein sources in our concentrate, right? So we need to build the energy equation. So the energy equation, as you can see here, is the multiplication of energy from energy ingredients times X, which is the amount of energy source ingredients in the diet, plus 1.52 is the energy amount in our protein sources times the amount of protein ingredients, which we call it Y, equals the target energy in our concentrate, which is the 1.65 that we calculated it in our previous episode. So the nutrient composition of the concentrate, the target value for energy was 1.65 and the target protein level was 17.5%. So here is the same idea. Remember, for the protein equation, it's a good idea to convert the percent to gram per kilogram. So to do that, you need to multiply the protein values by 10 to convert them from percent to the grams per kilograms. Why? Because here our energy level is based on kilos, right? For example, it is 1.65 megacalorie per kilos. And we wanna, make the units at the same basis, kilos. That's why for the protein, we wanna have the same idea, not going with percentage, just going with grams per kilograms. And in that case, our energy is based on the kilos, megacalorie per kilos, and our protein should be based on grams per kilo as well. So that's why if you look here, our target protein level was 17.5%. I multiplied it by 10, so I have 175 grams per kilos, the target protein level. So what was the protein level in my energy sources? It was 10.42%. Again, I multiplied it by 10. That's why I have 104.2 times X, which is the amount of energy sources, plus what was the protein level in my protein ingredients? It was 47.25%. So if I multiply it by 10, I'm going to have 472.5 grams per kilogram protein times Y. Y is the protein sources, amount of the protein sources in my concentrate. So, and my target protein level is 175. Here, there is a tip. You need to pay close attention to this. Your target value in each equation should be between the coefficients of X and Y. For example, here, my target level for energy is 1.65. As you can see, 1.65 is located between 1.87 and 1.52. This is greater than 1.52, and this is smaller than 1.87. So it is located between those numbers. And here, it's the same idea for the protein level. So my target protein is 175, which is larger than 104 and smaller than 472. So it is located between these two numbers. So it is really important. If your target value is smaller than both of the X and Y coefficients, in that case, it's not going to work. Or if it is, greater than both of them, again, it's not going to work. The target value should be located between those two coefficients of X and Y. So keep this in mind to have a right calculation. So now you're going to solve these equations, and it's simple. You can use any method that you like, but here is the method that I have used. So usually I start with the second equation. As you can see, I just bring the X parts or, X components to the left side and all of other components to the left side, because my goal is to find the equation based on X. So what I did, I just divided the two sides of the equation by the coefficient of X, which is 104.2. So 104.2 divided by itself, it's 1. So I'm not going to write 1. It's X equals 175 divided by 104.2. It's going to give me 1.67 minus 472.5 divided by 104.2. It's it's gonna give me 4.53 multiplied by y. So now I have the, I have a equation based on the x. What I'm going to do is I'm gonna plug these x values to the first equation. So in the first equation, I had 1.87x. I'm going to plug it in here. So I'm going to have 1.87 times, instead of x, I'm just writing this equation here, 1.67 minus 4.57y. So plus, continue just the first equation, 1.52y equals 1.65. Now, in this equation, the only unknown variable is y, and you can just find it easily. So it's going to give you 0.21 for y. So now you can plug it in the second or the first equation. It's up to you to find the x. Here, I just put 0.21 for y in the first equation, and I'm going to find the x. X value is 0.71. Now, I have found, both values, x and y. And we are not really doing pure mathematics. We are formulating a practical diet. So that's why my energy ingredients and the protein ingredients should add up to 100% or 1. That's why I need to double check this. I found 0.21 for y and 0.71 for x. If I add them up, it's going to give me 0.92, which is not 1, but my target is 1. So I need to adjust it. So see here, I'm saying if my x value is 0.71, the sum of x and y is 0.92. I want to have 1 for the sum of x and y. What should be my x value? So from here, I can calculate my final x value, which is the 0.77 or 77%. And if I have 77% x, which is the ingredient, energy ingredients, then I need to have 23% protein ingredients, which I call them y. So we will have 23% protein sources and 77% energy sources in the concentrate, as we calculated here. The values for protein sources, which was y, and the value for energy sources, which was x. Now I can calculate the percentage of ingredients in the final concentrate mix. So look, for barley, what I'm going to do is to say, okay, barley is located in the feed part, not the feed additives or not the slack space. And if you remember in the previous episode, I said we will have about 3% slack space in this concentrate, which doesn't have any energy and protein value. That is slack space part, which is the, feed additives. So that's why we decided to formulate the feed ingredients in 97%. Right? So 97% are, we will have the feed ingredients, and 3% we will have the feed additives or slack space. Now, I'm saying from that 97% feed ingredients, 77% is for energy sources, And from that energy sources, 60% is barley, as I assigned, in the previous slides. So the amount of barley in my concentrate should be 44.8. So I'm just multiplying 97%, the section for feed ingredients. I'm accounting for slack space. I'm not paying attention to that 3% slack space. Take it away. Just 97% feed ingredients. From 97% feed ingredients, 77% is for energy ingredients. And for that energy ingredients, 60% is for barley. What is the amount of barley in my whole concentrate? You can just, multiply these numbers. It's the same idea for corn. It's the same idea for the protein sources, except in the protein sources, instead of 77%, you need to use 23% because they belong to protein section, right? To Y section that we calculated in the previous slide. So now I have, the numbers for all of my ingredients, and you need to double check. You need to add them up. The sum of these ingredients should be 97. So 44.8% barley plus 29.9% corn plus 16.7% sunflower meal and 5.6% cottonseed meal, they should add up to 97%. And we have 3% slack space, right? So we're gonna balance the slack space area or feed additives. So we need to consider the calcium requirements and phosphorus requirements in this scenario. As you saw in the previous episode, we need to have 0.56% calcium in our concentrate and 0.35% phosphorus in our concentrate, right? So first, we're gonna add dicalcium phosphate to balance the phosphorus. See, here is a secret. Whenever you're going to balance calcium and phosphorus, we have two types of ingredients. Some of them can provide both calcium and phosphorus, like DCP, dicalcium phosphate. But some of them can only provide one of these minerals, which is the calcium here, right? So, for example, calcium carbonate can provide only calcium, not phosphorus. But dicalcium phosphate can provide both of them, calcium and phosphorus. So you can see calcium can come from two types of feed additives, can come from DCP, can come from calcium carbonate. So we need to keep that for the second step. So we need to balance the mineral that can come only from one source, which is the phosphorus. Phosphorus can only come from dicalcium phosphate, not from calcium carbonate in our diet. That's why we need to first balance the phosphorus, and then we can balance the calcium. So based on our feed ingredients table that I showed you in previous episode, so you can see dicalcium phosphate has 21% calcium and 18.5% phosphorus. So here, I'm just going to calculate the amount of dicalcium phosphate in the diet. I'm saying each 100 grams of dicalcium phosphate has 18.5 grams of phosphorus, as I showed you in the feed ingredients table. Now, I need to have 0.35% phosphorus. How much dicalcium phosphate I need to add, which is the X here. So just do a cross multiplication, 0.35 times 100 divided by 18.5, it's gonna give you 1.89% dicalcium phosphate. Now, this amount of dicalcium phosphate is needed in our diet, but it can provide calcium as well. So we need to calculate the amount of calcium coming from dicalcium phosphate. So in feed ingredients table, we saw dicalcium phosphate has 21% calcium, right? So calcium provided by DCP equals 1.89% dicalcium phosphate we're gonna use times 21% calcium. It's gonna give us 0.39% calcium. So we need to take this away from our calcium requirements because this much is provided already by dicalcium phosphate. So 0.56, the total calcium requirements minus 0.39, which was provided by the DCP, we will have 0.17 calcium shortfall that we need to provide it by adding calcium carbonate. So calcium carbonate has 36% calcium. So you need to say, okay, each 100 grams of calcium carbonate has 36 grams of calcium. I need to have 0.17 grams of calcium in my diet. How much calcium carbonate I need to use? So again, you can solve this for X. It's gonna give you 0.47% the value for calcium carbonate. So at the end of the day, it is the final formula for your concentrate. We calculated the amount of each ingredients in the concentrate, and you can see we have gathered those numbers in this table. So usually we use 1% calcium cattle premix in our diets. That's why it's based on the instruction provided on the premix label. You need to follow those instructions. If it says use it in, I don't know, 2%, you need to use that much. But for the product that I'm using, the recommendation is 1%. That's why I put 1%. Usually 0.5% salt. If you want, you can, calculate the amount of sodium and chloride in your diet, and then precisely you can calculate the amount of required salt. It would be the best way, but to keep our steps short and simple, I just calculated the calcium and phosphorus. But of course, you can calculate the sodium and chloride and balance those minerals as well to come up with a an accurate number for salt. So the idea is they should add up to 100%, right? Your formula should come to 100%. But here you can see it comes to 100.86. We have a little bit extra amount here. So you need to try balance it in 100% by deducting this extra amount, which is 0.86 from the energy ingredients. For example, let's say you can deduct this number from barley or from corn, up to you, just to calculate it, to balance it in 100%. So let's say if you go with 44.8% barley, it is 448 kilo per ton. So now if you want to adjust it by deducting, let's say 0.8, in that case, you need to have 440 kilo barley per ton. It's up to you, but you should not adjust this using the feed additives. If you say, okay, I'm going to deduct this extra amount from the dicalcium phosphate, no, you are not allowed to do that. It's really sensitive. We are not going to touch the additive section. You can go with energy ingredients. Again, I'm not suggesting, to deduct it from protein section, because protein is crucial, is the expensive part of the diet. We don't want to compromise the protein requirements, but for energy ingredients, you can do that, and you can just deduct these small extra numbers from either barley or corn, or from both of them, half from barley, half from corn, up to you. And the last step, we need to convert dry matter to as fed. So far, we have calculated 7 kilos forage in our diet, and we divided it to two sections, 3.5 kilos for alfalfa, 3.5 kilos for corn silage, and 12 kilos concentrate, right? And we already know the amount of dry matter in our ingredients. Now, to convert it from DM or dry matter to as fed, you need to divide the amount of ingredient by the amount of dry matter. For example, alfalfa has 88% dry matter. So I'm gonna feed 3.5 kilos alfalfa based on dry matter, but in reality, my alfalfa, at the farm, it has moisture in it, 12% moisture. I need to account for that. So 3.5 divided by 0.88 or 88% dry matter, it's gonna give me 3.97. You can just round it to 4 kilos. So you're gonna feed 4 kilos alfalfa to your cows. And for the corn silage, because it has, too little DM, or let's say just 35% DM. So if I just divide the amount of corn silage, 3.5, by the amount of dry matter, it's gonna give me 10 kilo. So in reality, based on as fed, I need to feed 10 kilos corn silage per day, because it has only 35% dry matter, which is going to provide energy, protein, nutrients, minerals, and 65% is just water. It's just moisture. And for the concentrate part, you need to, calculate the average dry matter in your ingredients, like in barley, corn, cottonseed meal, sunflower meal in our case, but roughly dry matter percent of concentrate part is 90%. That's why we just divide the amount of concentrate by the 90%. It's gonna give us 13.3, or round it to 13.5 kilos concentrate. So now we need to calculate how many cows we have in this situation, in this scenario, and in this group, and then calculate the amount of alfalfa, corn silage, and concentrate you need, then mix them together to make TMR, or total mixed ration, as you can see in this picture. One idea, traditional idea, is to feed the forage first and the concentrate after that, but the best way to feed your cows is just mix the forage and concentrate together and make the total mixed ration. By that, you're gonna, have a more sustainable environment in the rumen. So that's it. I explained the steps for dairy cattle feed formulation in 4 episodes. Of course, please let me know if you have any questions, and I'll see you in the next episode, hopefully formulating diets using commercial feed formulation software. Have a great day wherever you are, and I'll see you in the next episode. Take care.